Once there was a star. Like everything else, she was born, grew to be around 30 times the mass of our sun, and lived for a very long time. Exactly how long, people cannot really tell. Just like everything in life, she reached the end of her regular star days, when her heart, the core of her life, exhausted its fuel. But that was no end. She transformed into a supernova, and in the process, releasing a tremendous amount of energy, outshining the rest of the galaxy, and emitting in 1 second the same amount of energy our sun will release in 10 days. And she evolved into another role in our galaxy. Supernova explosions are very extreme, but the ones that emit gamma rays are even more extreme. In the process of becoming a supernova, the interior of the star collapses under its own weight, and it starts rotating ever faster, like an ice skater when pulling their arms in close to their body. In that way, it starts rotating very fast, and it increases powerfully its magnetic field. The matter around the star is dragged around, and some energy from that rotation is transferred to that matter, and the magnetic field is increased even further. In that way, our star had extra energy to outshine the rest of the galaxy in brightness and gamma ray emission. My star, the one in my story, became what is known as a magnetar. And just for your information, the magnetic field of a magnetar is 1,000 trillion times the magnetic field of Earth. The most energetic events ever measured by astronomers carry the name gamma ray burst, because we observe them as bursts or explosions, most strongly measured as gamma ray light. Our star, like the one in our story that became a magnetar, is detected as a gamma ray burst during the most energetic portion of the explosion. Yet, even though gamma ray bursts are the strongest events ever measured by astronomers, we cannot see them with our naked eye. We rely on other methods in order to study this gamma ray light. We cannot see them with our naked eye. We can only see an itty-bitty tiny portion of the electromagnetic spectrum that we call visible light. And beyond that, we rely on other methods. Yet as astronomers, we study a wider range of light, and we depend on other methods to do that. On the screen, it may look like this. You're seeing a plot. That is a light curve. It's a plot of intensity of light over time. It is a gamma ray light curve. Sighted astronomers depend on this kind of plot in order to interpret how this light intensity changes over time. On the left, you will be seeing the light intensity without a burst. And on the right, you will be seeing the light intensity with the burst. Early during my career, I could also see this kind of plot. But then I lost my sight. I completely lost my sight because of extended illness. And with it, I lost the opportunity to see this plot and the opportunity to do my physics. It was a very strong transition for me in many ways. And professionally, it left me without a way to do my science. I longed to access and scrutinize this energetic light and figure out the astrophysical cause. I wanted to experience the specious wonder, the excitement, the joy produced by the detection of such a titanic celestial event. I thought long and hard about it, when I suddenly realized that all a light curve is a table of numbers converted into a visual plot. So along with my collaborators, we worked really hard, and we translated the numbers into sound. I achieved access to the data, and today I'm able to do physics at the level of the best astronomer using sound. And what people have been able to do, mainly visually, for hundreds of years, now I do it using sound. Listening to this gamma ray burst that you're seeing on the screen, brought something to the ear beyond the obvious burst. Now I'm going to play the burst for you. It's not music, it's sound. This is scientific data converted into sound, and is mapped in pitch. The process is called sonification. So listening to this brought something to the ear besides the obvious burst. When I examined the very strong low-frequency regions, or baseline, I'm zooming into the baseline now, or the baseline, we noted resonances that were characteristic of electrically charged gases like the solar wind. And I want you to hear what I heard. You will hear it as a very fast decrease in volume. And because you're sighted, I'm giving you a red line indicating you what intensity of light is being converted into sound. It's frogs at home. Don't pay attention to that. I think you heard it, right? So what we found is that the bursts last long enough in order to support wave resonances, which are things caused by exchange of energy between particles that may have been excited that depend on the volume. You may remember that I said that the matter around the star is dragged around. It transmits power with frequency and field distribution determined by the dimensions. And you may remember that we were talking about a supermassive star that became a very strong magnetic field magnetar. If this is the case, then outflows from the exploding star may be associated with this gamma ray burst. What does that mean? That star formation may be a very important part of these supernova explosions. Listening to this very gamma ray burst brought us to the notion that the use of sound as an adjunct to visual display may also support sighted astronomers in the search for more information in the data. Simultaneously, I worked on analyzing measurements from other telescopes, and my experiments demonstrated that when you use sound as an adjunct to visual display, astronomers can find more information in this now more accessible data set. And this ability to transform data into sound gives astronomy a tremendous power of transformation. And the fact that a field that is so visual may be improved in order to include anyone with interest in understanding what the heaven lies is a spirit lifter. When I lost my sight, I noticed that I didn't have access to the same amount and quality of information a sighted astronomer had. It was not until we innovated with the sonification process that I regained the hope to be a productive member of the field that I had worked so hard to be part of. Yet information access is not the only area in astronomy where this is important. The situation is systemic, and scientific fields are not keeping up. The body is something changeable. Anyone may develop a disability at any point. And let's think about, for example, scientists that are already at the top of their careers. What happens to them if they develop a disability? Will they feel excommunicated as I did? Information access empowers us to flourish. It gives us equal opportunities to display our talents and choose what we want to do with our lives based on interest and not based on potential barriers. When we give people the opportunity to succeed without limits, that will lead to personal fulfillment and prospering life. And I think that the use of sound in astronomy is helping us to achieve that and to contribute to science. While other countries told me that the study of perception techniques in order to study astronomy data is not relevant to astronomy because there are no blind astronomers in the field, South Africa said, we want people with disabilities to contribute to the field. Right now, I'm working at the South African Astronomical Observatory at the Office of Astronomy for Development. There we're working on sonification techniques and analysis methods to impact the students of the Athlone School for the Blind. These students will be learning radio astronomy, and they will be learning the sonification methods in order to study astronomical events like huge ejections of energy from the sun known as coronal mass ejections. What we learned with these students have multiple disabilities and coping strategies that will be accommodated. What we learned with these students will directly impact the way things are being done at the professional level. I humbly call this development. And this is happening right now. I think that science is for everyone. It belongs to the people, and it has to be available to everyone because we are all natural explorers. I think that to unwittingly limit people with disabilities from participating in science will sever our links with history and with society. I dream on a level scientific playing field, where people encourage, respect each other, where people exchange strategies and discover together. If people with disabilities are allowed into the scientific field, an explosion, a huge titanic burst of knowledge will take place, I am sure. That is the Titanic burst. Thank you. Thank you.